Okay, so we can start now. So, good afternoon, everybody. So as I told you before, in this chapter, I'm gonna teach assembly instructions. After I finish this chapter, you should be able to write assembly programs for ARM processors, okay? So as you see here, in the first part of this chapter, I'm gonna talk about the program structure in general, the program, how the general structure of the program. Also, I'm gonna talk about how can you define variable, similar to, you remember integer x, double y, you remember when you define variable, I'm gonna do the same thing here. After that, I'm gonna start teaching instructions, and I classify these instructions this way. Number one, data transfer instruction, arithmetic instruction, shift and rotate instruction, branch and loops, and finally, I'm gonna teach stack and subroutines, okay? So as I told you last time, and as you saw in the first lab, the way we are gonna write the assembly programs, we are gonna have two different areas. One area to write the code and one area to write the data, okay? And when I say data, as you will see right now, I mean any variables. Any program, usually we have variables, we have arrays. You need to define these variables arrays. You have to assign to location for them, physical locations in memory. This is what you didn't see in C language. For example, in C language, when you say you did something for sure, you did something like that, integer I, right? You know, when you do something like that, you are gonna, in the memory, you are gonna take a physical part of the memory, you are gonna call it I, right? So every time you write to I, I'm gonna write to these physical locations, or read from this, exactly same thing we are gonna do here, okay? So as you see here, your program should have at least one part. Maybe in your program, although this is very rare, in your program, you may not have data. It's very rare, but it can happen, right? You don't have variable, you don't have arrays, but at least you should have. So this is one area, so for the code, and one area for data if you have, okay? So as you see here, so how, and that's so how can you create an area, or first of all, as I explained to you before, why you made it this way? We make it this way simply because this, whatever the instruction you are gonna write here in this area is gonna be written in the flash memory, the read-only memory. Is that okay? But this part is gonna be written in the RAM area. So this part is gonna be written in the RAM area. That's why we split them this way. Anyway. So, and that's what you are gonna see and that's actually, that's what we did last time. And that's what we are gonna do in every lab. Last time, the machine code was written starting from a certain location. I think it was 0x something, right? Because this is a flash memory area. This one was written from 000 because this is starting from the RAM area. Anyway, so the way you are gonna do it, as you see here, you have to use the keyword area, okay? And then you can write whatever here, any name for this area. For example, because this program is copying a string, it's gonna copy a string to another string. So that's why I'm gonna call it string. So it can be any name, it doesn't matter. You have to write here code, you have to write read only, or even if you don't write read only, usually the code is gonna be written in read only memory, in the flash memory, okay? So that means in this part will be for code. Okay, same thing. I'm gonna do the same thing as you see here, but for data, again, you have to use the keyword area. Here it can be any name, and then here you have to write data. And you can write read and write. If you don't write it, automatically it's gonna put it in the RAM anyway. Okay, so and also you can see here. So all variables should come here. Any if you want to define variables, arrays, everything should come here, as I'm going to explain today. Okay. For your program, this is your program. These are the instructions of your program. Okay. Don't worry, I didn't teach them yet, but your program should come here. Okay. So also your file has to end with the keyword end. So at the very end, at the end of your file, you have to put the keyword end. Okay, just to tell the compiler this is the end of the file. Okay. Also, as you see here, similar to the C language, in C language you have the main function and you can have other functions. Is that okay? Is this, we are going to do the same thing here. So as you see here, if you want to define a function, all what you have to do, you have to put a name, whatever the name is. But this is for the main. We have to put this way for the main. For the main, you have to put this name. Okay. So you have to put this name for main, and then you have to write procedure. So procedure means function, as you know. Okay. So procedure or routine or subroutine or function, all of them means the same thing. Okay. So that means this is the beginning of the function and this is the end of the function. Okay. That means here I defined one function. If you want to define more functions, as I'm going to teach later, yes, you can define more functions if you want. Is that okay? So this is similar to the C language. Here I'm going to have the main function. Okay. And similar to the C language, when you run your program, so you are going to start running the program from here, from the main function. Okay. Also, as you see here, you have you have to use the keyword entry. So entry should tell the link, the compiler, this is the beginning. You have to start from here. This is the entry. Okay. So you have to just write it before the main. Also, you have to say export, and then you have to put the main. Okay. This one for the linker. The linker should link several files together to make the main feasible to the linker. So we're gonna do it all the time. So let me tell you the conclusion before I give you more details. The conclusion is your assembly program should have two parts, as you see here, one for code, one for data. Okay, and you have to end it, you have to put in that's in. Any variable definition should be here. Okay, if you want to define variable arrays, everything should be here. Okay, and whatever you write here is going to be stored in RAM. Okay, for example, in your last project, your the RAM started from 200. Okay, 000. That's why you can see all these data stored starting from this location. Okay, all the time we're going to do all of that. So here, this is the main. So your program has to come here. Your program has to come here. If you have other functions, you can add them here. Okay, so this is the general structure for the program. Okay, also you can see here, guys, similar to any programming language, we do some kind of command. You can add comments similar to any programming language. But you know, in C language, we can use double backslash, or you can use slash and then asterisk slash. This time here in assembly, you use semicolon, as you see here. Okay, and it's not mandatory, so it's optional. So it doesn't mean because I write here in everyone. So some students are confused, and you have the right to be confused, because in C language, every line I have to end it with a semicolon. It's C language, right? Here, this is not the case. This is not the case. You don't need to end any line with semicolon. You don't need. Semicolon means whatever is going to come after this one is a comment. Okay? That means if you don't have any comment, just don't put anything. Don't put semicolon. Is that okay? Don't put it. That's okay. So here you don't need to end every line with semicolon. Okay. So anything you know from any programming language, comments are just used for human. They are not instructions. Okay. As I'm gonna explain, they are used to improve the readability of the program. Okay. Any questions? Okay. So that's what I said here, guys. We can put some comments here if we want. It's not. It's optional. It's optional. Also, one more thing you should know: in our program, we're gonna have instructions and we're gonna have directives. So, what is the difference between directives and instructions? Instructions, these are the instructions that have machine codes. These are the instructions that are gonna be converted to machine code and executed by the processor. Right, similar to these instructions. So these are instructions I'm gonna teach, right? So like load, store, compare, branch if not equal, and so on. So all these instructions, these are instruction commands. to the microcontroller. Okay, so all these instructions are going to be converted to machine code, stored in the flash memory as you did in the first lab. Okay, okay, but what about directives? Directives, you can tell this is just you want to give some information, or I want to give some instruction to the compiler. Okay, so this is just information to the compiler. They are not gonna, they have nothing to do with ARM processor. Okay, they are not gonna be converted to machine code. You want to tell the compiler to do something like what? Like what I did here when I say area. I just want to tell the, when I say this is the end of the program, all of these are directives. You understand what I'm saying, guys? So when you say I want to store this one in memory, so all of these are directives, are not going to be converted to machine code. So again, I'm going to give you talk more about this one, but for now you should understand not everything you are going to write here is going to be executed by the ARM processor. Not everything is going to be converted to machine code. Okay, because we have to write some instructions here for the compiler. They are not converted to machine code. Okay, like for example area, as I explained, and so on. So here in this table, I summarize the main directives we are going to use. As I'm saying here, directives are not instructions to the ARM processor. Instead, they used it to just to provide some information to the for the assembler or to the compiler. They are not going to be executed by the microcontroller, are not converted to machine code. Okay, they usually used in order if you want to define some variables, okay, or for the structure of the program. So I already explained area, you remember. One more thing very important before I forget, because you may have errors because of that. Listen to I'm gonna so also we have something we call it a label. Label is just an English name. Okay, I use it. For example, let's see what labels we have here. We have for example the word loop. The word loop is just it's a label, just a name. Okay, it's not a keyword. It's not a keyword, just a name. You can call it any other name. Okay, so what happened is that, so for this instruction, what happened, I have a branch instruction here. So when I come here, so this instruction is going to check a condition. If this condition is true, it's going to branch to somewhere. Okay, so you have to name this line because I need it. You got what I'm saying? So what happened here, this line, I'm going to put here a label. Can be any name, because this instruction I'm going to say you have to check something here, and if the condition is true, please you have to jump it where you have to jump to this line. You understand what I'm saying? Same thing when you define variables. For example here, and as I'm going to explain in details, this is here I'm going to define a message. Okay, I'm going to define a message. So here's the way I'm going to define this, the source string. Okay, the way I'm going to define it, as you see here, I'm going to put a name, like similar thing, guys. When you say, for example, integer I is just a name. Okay, so this is also another label. So just to summarize what I said, in your program, you may need to have labels. Even the name of the function itself also is a label. So you may need to have labels. This again, this label just English names. Okay, they are not. Sometimes I use something like keyword, like the word loop, right? But actually, it's somehow confusing. You may think loop in instruction. No, it's a label. It can be any name. I can call it any name. Okay. So same thing for stop. So stop here is just a name, any name. Okay. So, and sometimes I do need to put a label. For example, for this instruction, there is no label here because I'm not gonna jump to this instruction. So why I should put a name for this instruction? I don't need, right? Because I'm not gonna jump here. Okay. That's why for you may not need this one. Okay. So because I'm not gonna use it here in the code. Anyway. It's not wrong to put it, but it doesn't make sense. Okay. So anyway, same thing when you have a variable like integer x, or integer sum, integer speed. All of these are just names. We're going to put them here, labels. So what I want to tell you here, because you may get error because of that, if you have a label, you should start the label from the very beginning. You should not leave any space. You got what I'm saying? Anything else other than a label, you have to leave at least one space. Otherwise, you will get error, right? That means, for example, this instruction here, if I don't leave any space and start from the very beginning, if I don't leave any space, start from the beginning, the compiler will give you error. It's going to tell you, I don't know, because what's going to happen, the compiler is going to think this is a label and this is the instruction. So it's going to tell you, I don't understand this instruction, which is for sure is not true. So conclusion, same thing for everything else. For everything else, you have to leave at least one space. You know what I'm saying? Conclusion. Number one, in your program, we need to use labels. Okay. If you use a label, you should not leave any space, right? So it has to start from the very beginning. But if there is no label, you have to leave at least one space. Otherwise, you are going to get an error. Okay, guys. So these are labels here. That's why you can start from the very beginning. Any label can be any name. Okay. And they are used to name functions. They are used to just to make like identifier or a name for a line, so that when I do jump, I'm gonna say jump to here. Okay. Or here I'm gonna say jump to here. Okay, jump to here. Anyway, so also if you have an array, if you have variables, so you can put also labels here for this array and variable, and you can use it later. That's what we did in the last lab. You remember when we have sum? Okay, it was just a variable. I call it sum. Okay. One more thing important you will see tomorrow. When you put a label, the code word is the compiler is going to actually replace this label with the address, with the physical address. Okay, what do you mean? I'm going to tell you what I mean. For example, here I'm going to say branch if not equal, okay, to loop. What's going to happen if this instruction starts at the location, for example, 800700, just any number, okay? So if physically this instruction is gonna start from this location, what's gonna happen? The compiler is gonna replace loop with this number. So I'm gonna say, okay, so if you wanna jump, I have to jump to this physical location. Is that okay? Same thing for if you have here this one. But as you will see tomorrow, this is an array. So this array is going to be stored in several locations. Okay. So as I'm going to explain now in details. So this array here, guys, how it is stored in memory. For example, if I start from location 20000, this is the beginning. So the ASCII of T is going to come here. It's going to take 1 byte. The ASCII of T, right? The ASCII of H is going to come here. It's going to take 1 byte, and so on. Finally, 0 is going to come here. So this is an array of bytes. Okay, and that's what you will see tomorrow. Okay, you are going to have something like that. You are going to go to the memory. You see how it is stored in memory. This one is going to store in ASCII because you put quotation here. Because of this quotation, you are telling the compiler this is a message. Okay. And this message is going to be like array of bytes, and every location in the byte you are going to store the ASCII of one, even space. It has an ASCII which is 20 hexadecimal. So you should be stored this way. So let's come to my point. My point is that this is an array. This array is going to take, for example, 10 bytes, 20 bytes, whatever. It depends on how many. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, and there is a space here. Okay. 18 and 0, 19. Okay, so it's gonna take some 19 bytes. Okay, that means you have 19 addresses. the compiler is going to replace the label with the address. Which address? We have 19 addresses because we have 19 locations. Okay, as you will see tomorrow. So actually, this one is going to be replaced by the beginning address, the beginning one, the first one. Okay, same thing if you define a word, because word is going to take 4 location. Same thing if you define half a word is going to take 2 location. 2 location means 2 addresses. So if you put a label here, which address? Okay, same thing even for this instruction, because this instruction is going to take 4 locations, so it should have 4 addresses. So when you tell me this label is going to be replaced by address, tell me which one, the first address. You understand what I'm saying? Anyway, so I'm going to give you more details. But at least for now, I'm telling you, just let me return back to my main point. My main point is that if there is a label, you should not leave a space. Okay, so it should start from the very beginning. If there is no label for anything else, directive or instruction, you have to leave at least 1 space. Otherwise, the compiler is going to give you error. Is that okay? Now, so this is the first directive I told you. So now also I'm expecting you understand the difference between instruction and directives. Okay, so directives are information, or you can tell instruction or information to the compiler. They are not ARM. They have nothing to do with ARM processor, or they have, so let me be more accurate. It has nothing to do with assembly instructions. You got what I'm saying? They are not assembly instructions. They are not going to be converted to machine. They are not. Okay. So anyway, also some of the directives here I'm going to also explain is end. As I told you about end, it has to be at the end of the program. If you want to create a function, you have to start with this one and you have to end with this one for any function you are going to create. Also, we have other things like export, like include, okay? And also we have here equate. So I'm gonna explain them. All of these are direct, so I'm gonna explain them in more details. And also more importantly, so these ones here, these instructions are used to define variables variables and arrays. Okay, so you can think about them. They are like integer. When you say integer I, okay. So instead of saying integer I here in assembly, you are going to use these ones. Okay, as you will see now. So let's see. So for example, I already explained the area. Okay, I don't think I have anything here more. Okay, so here at least your program should have, as you see here, two areas. Okay, one for the data, one for the code. Also, I explained about entry. So entry should mark the start point of the to execute a program. Okay, so you have to tell this is the beginning here. A program should start from here. Okay. Also, any file, it has to end with the key, with the directive end. Okay, so directive here is a keyword. Okay. Anyway, also any function, or we call it a procedure or subroutine or function, all of them it's the same meaning. Okay, so any function should start with this one, end with this one, and here this is the name of the function. So if you want to define another function, you can just put a name and then you use these two. Okay, and similar to the C language, we should have main function. Okay, you have to use this export in order to make this main function feasible to the linker. Okay, linker is a program that link different files together. Okay, anyway, now I'm gonna explain the directives that are gonna be used to define variables and the arrays. Is that okay, guys? Any questions? So now I'm gonna explain now. Tomorrow, as I said in my email, we are gonna have a very short lab, because I didn't teach on Monday. Okay, so I didn't teach much. So and also I'm gonna teach you for 1 hour. Okay, so in tomorrow's lab, I'm going to focus on variable definition. How can you define variables? So it's related to what I'm going to explain. Right. Also, there will be a quiz on this part. It's very easy. I know I put myself in the position of students. I hate that I teach something today and test you tomorrow. And I hate it's not good for sure. but at least I will try to avoid for sure something like that. But at least for this one, this is very easy. It's not difficult. This is like integer I or something like that. If you understand one example, it's going to be too easy. That's why this time should be okay. Yes. So the quiz will only give every single chapter. No, it's going to be only this part. I'm going to after I finish it, I'm going to tell you what I'm going to. Just let me finish it first. Okay. So now I'm gonna explain how can you define variable or arrays. Okay, guys. First of all, before I start here, when we say what kind of variables we have here, this is somehow different from assembly. You remember in assembly we had integer, we had double, we had long, we had too many things, right? Here you can make a variable of 1 byte. Okay, so or array of bytes. Okay, so your variable can be only one variable of byte, or it can be array of bytes. Okay, in order to do that, I have to use this keyboard, this keyword. I have to use this keyword, define constant byte. Okay, by the way, I know this also may be confusing because we call it constant, but actually it's not constant. So it's going to be a variable. You can change it. Okay, I know we use the word constant in C language. If something we are not going to change. Okay, so here constant, it means it doesn't mean it's still a variable. Okay, so here we are going to use this keyword if you want to define a byte variable. Byte, again, keep in mind assembly, we don't have integer, we don't have float. Instead of integer float, we are going to do something else. We are going to do byte. We have byte. You can define variable of a byte, array of bytes, and so on. This number one. Number two, we have half word. You know, byte means 8 bits, right? Half word means 2 bytes. Yes, you can have your variable half word, or it can be word. So I can create a variable of word. You know, in case of word, every element, the variable itself should be 32 bits. In other words, it should be 4 bytes. In other words, it should take 4 locations in memory. Okay, so let me say it slowly. So now all what we have, guys, only 3 things. It can be byte, okay? It can be half word. It can be a word, okay? Byte, and for every one of them, it can be a variable. If it's only one thing, a variable, or it can be array. So you can create array of bytes, array of words, array of half words, and so on. Okay. So how they are different? Okay, space, different in space. So if you have a variable of byte, so as I explained in chapter 1, you can store from, if it is unsigned, from 0 to 255 in case of a byte. For sure, in case of a half a word, you can store bigger number because it's a bigger space. In case of byte, it's going to take only one location in memory. In case of byte, in case of half word, it's going to take 2 locations because it's 2 bytes. You understand what I'm saying? Makes sense, right? Also, same thing for a word. It's going to be, because it's 32 bits, it's going to take 4 locations in memory. Okay. Yes, it is one variable, but I have to break. I have to cut it, right? Because in memory, in every location, we cannot store more than a byte. So I have to cut it into 4 bytes, as you will see right now. So it has to be stored in 4 locations. Okay. Yes. Go back a slide. Show the array. You have it as a word. Which one? Which slide? On this slide right here, where it's at the top, we're using a constant word or 5 variables. Well, 5 variables. Here? Yes. Man, just to give me a second. I didn't explain it yet, so I'm gonna start. This is here. You define array. You define array of words. You get what I'm saying? So let me finish it, and then you can ask if I didn't address your question. Okay? Just give me more time to finish it. Okay? So here, as I told you guys, if you want to define a variable byte or array of bytes, just use this one. Define constant byte. If you want to define a variable half word or array of half words, you have to use this one. DCW, okay? If you wanna define array of words, you have to use this one. That's exactly. You can, but maybe this Also, you can here use double word. So double word is going to take 64. I just mentioned the first three because most of the time we are going to use this three, but you can, it's the same idea. If you have, if you make a variable that's double word, you can use this one. Okay. So, and also we have another thing here. I'm going to explain it. We call it space and the fill. So let me go through them one by one. Okay. So number one, make it very easy. So number one, again, anything I'm going to explain right now, guys, it has to be here. It has to be under the data area. Anything I'm going to explain here, it has to be under the data. So let's start with the first one, DCB. Okay. And it's just very simple. Okay. So here. Okay. So for example, if I want to define a variable byte, it's called, I'm going to call it sum, any name, sum. Okay, how can you do that? Very simple. I'm going to make a label. I'm going to call it sum label. Okay, that's what you need for the tomorrow quiz and also lab. Okay, so if you want to define a variable byte, all what you have to do, just you can call it any name, and it has to start from the very beginning, as I told you, and then you have to use this one, DCB, define constant byte, and then you have to put the initial value, whatever you want to store here. You want to store 0, okay? Whatever you write here, keep in mind, this is a byte, right? That means if you write it, you have to make sure the initial value right here, it should not exceed the limit of, it should be, a byte should be enough, makes sense, right? So I cannot say, for example, I'm gonna store 0x3af2. That's not true, right? Because this one needs a byte is not enough, okay? So what I wanna say, here you put the initial value here. Is that okay, guys? And the initial value here, you can write it, if you want to write in decimal, it's okay. You can write it in binary. You can write it in hexadecimal, okay? You don't need to do any conversion. I found it before because most of the time I use hexadecimal. Some students think that it has to be hexadecimal. No. For example, if I say DCB, define constant byte, 27, that's okay. Or I can say 0x3a, that's okay. Or you can say -20, okay? Still it's gonna be a decimal. If you want to do it in binary, we're gonna do 2 underscore, or sorry, 2 underscore, as you see here, not 0b. The compiler does not accept this prefix, so it has to be 2 underscore and then put a binary number like 1110111, whatever. Okay, so you can use any format of this one. Okay, guys. Okay. So, and actually what happens, for example, if I do it here, if I do this sum here, assuming, so if I say here, as I have just mentioned, sum DCB, and then for example, 0xff, okay? So what's gonna happen here, this instruction is gonna take one memory, if my memory started from 2000, if this is the beginning address of the memory, so the first one, the first location here is gonna store FF, okay? And in your program, if you use the word sum in your program, sum is gonna be replaced by this address. Is that okay? That's what I told you. When you use a label, the label is gonna be replaced by address, okay? Because so what if I make another, so after this one, I'm gonna make, for example, speed DCB 0. So how this one will be stored? Okay, this one is gonna take byte. This one will be the next byte. You got what I'm saying? So as you will see, I'm gonna make some definition. So one by one, they are gonna be stored in memory. So this one is gonna be at 2000. The other one should be at 2001. Sorry, it's not 2000, 20001. Okay, this one. So it's gonna store here 0. So it's the next location. So every time I make a definition here, it's gonna add it to the memory. And this is easy case because everyone here is gonna take only 1 byte. That's totally fine. Okay. If I define a word, so the next 2 bytes are gonna be for the next one. Yes.
you answered my question. It was just about the fact that on this page it shows DCD is defined constant byte, but earlier it does say allocate one or more bytes. So when you would use DCW or DCD, if you can do more than byte DCD, or also how because
I'm gonna answer it right now. How you can do that? We define array of bytes.
Okay.
So it's coming now. Okay. So what I explain right now, guys, because the same keyword. So what I did here, guys, in these two simple examples, okay. Again, I'm gonna repeat two important things, guys. Listen to me. Number one, any variable you write here, when you initialize it, you can initialize it with any number system. Okay. All what if you put 0x, that means this one is a hexadecimal. If you put nothing, that means it is decimal. If you put 2 underscore, that means it's binary. This number one. Number two, okay. When you define a variable, you can put English name, any name, right? English name. And this English name is going to be replaced by the beginning address, right? Because that's what I'm going to use later in the code, as you will see, right? So, for example, if you have array and I want to scan the array, how I do this? I'm going to take the name of the array. The name of the array is going to give me the beginning address. I'm going to put it in a pointer, and then I'm going to read a byte pointed by this pointer. So now I got first element. Then I'm going to increment the pointer by 1. Why by 1? Because it's array of bytes. Then I'm going to read the byte from this location pointed by the point. Then increment the pointer by 1, and so on. Anyway, but if it is array of half words, so every time I'm going to increment the pointer by 2, right? Because if you have here, I'm going to read a half word. I'm going to read 2 bytes, right? Because every element should be 2 bytes. Anyway, and then increment the pointer by 2, right? Anyway, it's maybe too early, but that's what you are going to see later. Okay. Anyway, so now let's come. So what I want to say, this one is used. This one is used if you want to define a variable byte. Also, the same keyword can be used if you want to define array of bytes. Array of bytes. How can you do that? Very simple. For example, I'm going to call it array. Again, this is not a keyword. Can any name, right? So I'm going to call it array. Then I'm going to say define constant byte. Okay. And then I'm going to say 2, 7, 5, 20, for example. Okay. That's it. So this is the difference between, for example, here, if you say speed TCP 20, for example, because you put only one element here, so this is a variable. However, if you put here multiple values separated by comma, that means this is array. So now I want to create. Look, this is a difference. The same keyword can be used, but here if you put only one value, it's going to be a variable. If you put more than one value separated by commas, so this actually every value is going to be in one location. So for example, this one, I have how many bytes? 1, 2, 3, 4. And how this one is going to be stored in memory? I'm going to tell you. Assuming we're going to start, assuming this is the first one after this one here, after this is the first one. Okay, because we're going to start from the location 2000. So what's going to happen is, okay, look here, guys. Location 20000000. Okay, what's going to happen? Number 2 is going to be stored here in this location. Okay, then so every element is going to take 1 byte. Very simple, right? Because this array of bytes. 7 is going to come here, which is at location 20000001. Okay, 5 is going to come here, and so on. 20 is going to come here. So this one is you are going to see in the memory. You are going to see this one is going to take 4 bytes for location. Is that okay, guys? And now, so now you have 2000, 2000. You have 2001. You have 2002. You have 2003. Yes. So this array is going to be stored in these 4 locations. That's true. So now in my code, when I use the word array, I told you before, every time you use a label, the label is going to be replaced by address. If this is label is a label for instruction, so it's going to give you the beginning address of the machine code of this instruction. Okay. So now we have 4 locations. So when I use array in my code, array is going to be replaced by which one? Which address? Okay. As I told you, it's going to be replaced by the beginning address, which we call the base address, base or the beginning address. Is that okay? That's what you will see tomorrow. Okay, so when I use the word array in my code, it's going to be replaced by the beginning address. Okay, guys, any questions? Okay. And the beginning address doesn't need to be 2000. This is only for the first variable, because any definition after that, this one will come after it. You understand what I'm saying? So we start from the location 2000. And then every time you make definition, I'm gonna add. Okay. So very simple, very easy. So this is how can you define a byte variable, initialize it. This is how can you define array of bytes. Any questions? Okay. Now, if I want to define half word instead of a byte, half word, how it would be different? I'm gonna repeat exactly what I explained right now. Exactly. There are two things are different. Number one, I'm going to use a different keyword. Okay, that makes sense. This number one. Number two, because this is these are half words. Everyone, so this one is going to take 2 locations in memory. This one is going to take 2 locations, 2 locations, 2 locations, 2 locations. You got what I'm saying? So whatever you are going to write in, instead of taking 1 location, it's going to take 2 locations in the memory. Okay. So this is the second one here. DCW. Okay. So let me give you examples. Again, assume I'm going to say something like, for example, speed DCW, for example. Then I'm going to say 0x3AF2. Okay, it's a word here. And then I'm going to say array 1. Again, so just a name, any name. DCW. Okay, and then I'm going to say 3, 7, whatever 0xFF, whatever it is. Okay, so how this one will be done? Okay, so what's going to happen? Again, assume I'm going to start from 20000. This is my beginning. So that means this element is going to take 2 locations. It's going to take 2, right? So it's going to take 2 locations, 2000 and also 20001. 2 locations. It's going to be stored across 2 locations. Is that okay? Okay. Next one, exactly same thing. Here I want to store number 3. Same thing. This one is going to take 2 locations, starting from 2002. 2003. It's going to take 2 locations. Next one is going to take 2 locations. Next one is going to take 2 locations. Okay, guys? That's because this is what the keyword is going to do. It's going to, every element here is going to be stored in half word, right? Any questions? Someone can tell me I'm confused because this number 3, I can store it in a byte. You got what I'm saying? Yes, number 3, you can store it in a byte, you can store it in half word, you can store it in a word, you can store it in any space. You got what I'm saying? But what I want to tell you, yeah, this is initial value. So here I'm gonna make array of words. Why array of words? Because that's what I need. This variable, maybe later, this is just the initial value. Maybe later I'm gonna put big numbers because I have big containers. You understand what I'm saying? I have big containers, so I can add big numbers. But again, the way it should be stored is if number 3, if it is in a byte, in hexadecimal, should be stored 03 hexadecimal. But if it is in a word, it should be stored 0003. If it is in a word. Okay. Any questions? Any question, guys? Pretty easy, right? So now, if your variable have a word, number 1, you have to use this keyword. Again, if it is just a variable, you can put here 1 value. If it is array, you have to separate it by commas, as we see here, commas, as we see here. Is that okay? Okay. What else do you have? I'm gonna repeat the same thing again. What if your variable, I'm gonna repeat again. It's the same thing, I'm gonna repeat it again. But what if your variable is a word? How it would be different? Same thing. Number one, there are two things are different here. Number one, I have to use a different keyword. So instead of using DCW, I'm gonna use DCG. This is number one. Number two, every element is gonna be stored in 32 bits. 4 locations. Yes, that's true. Okay. That means if I say here, for example, DCD, okay. For example, if I say I'm gonna define a variable, for example, I'm gonna call any name like sum or whatever, DCD, okay, and then I wanna store in this location, for example, 0xFF3A, okay, and BBCC, right? So because this is 32 bits, that means I can write up to 8 digits, right? Every digit is 4 bits. 8 times 4 is 32, okay? So for example, if you write something like that, if you are gonna start from location 2000, if this is the first instruction, okay? I'm gonna start from 2000, okay? That means this one is gonna take 4 locations, 4 locations. So that means sorry, it's not 2000, it's like a big one, so it's 200001, okay? 2 6 zeros and then 1, right? Because total should be 8 digits, but anyway. So I mean 2000, okay? This one, and then next location. This is if we start writing from this location, and then or in other words, if our RAM starts from this location, then 20001, and then 2002, and then 20004. Okay, so that means my number here is going to occupy 2 locations. It's going to 4 locations in memory, starting from something is wrong. This is 3. Okay, 0, 1, 2, 3. 4 locations. Is that okay? So this one is going to be written in 4 locations. Okay, guys. Same thing if it is array. Exactly same thing. For example, if I have here, just I think I received a question here. Here, DCD. Okay, so this one is array of words. That means this one is gonna take 4 locations. I'm gonna put them in 4 locations. For sure, you are gonna have zeros, a lot of zeros, for sure, because this is just number 1, right? But still, it's gonna be stored in 4 locations. Okay, so here is gonna be 4 locations. This one is gonna be next to 4. This one is going to be next to 4. This one is going to be next to 4. Is that okay? So that means how many locations this array is going to take? 1, 2, we have 5. We have 5 elements. Every element is going to be stored in 4. So total, we have 20 locations. 20 locations or 20 addresses. However, when you use the word array, so array is going to be the base, the beginning one. Because we have 20 addresses, we have 20 locations. Any questions? Yes, sure.
For the end of an array, I thought I remembered in C there being something about how you need something similar to a null terminator, or at least we do with linked lists where you need to point it to null. So is there not a location you would need after the last array element to do that same function?
Okay, so the question is that when I use this one in a program, do I need to put a null, or a null is a special number, is gonna tell me this is the end. Sometimes we call it a delimiter. Okay, delimiter. So delimiter means a special character to tell me, okay, there are 2 approaches. One approach, if you call a function, for example, if you have an array, okay, and you call a function, I can tell the function my array has 20 elements, right? So in this case, you don't need a delimiter, okay? Because I'm gonna tell the function how many. So I'm gonna send the array to a function. For example, I wanna scan it. So all what I need to do, I just tell the function you need to loop. For example, or number of elements are 20, right? There is a more flexible way to do that, which is I don't need to worry about how many elements I have. Okay, I'm gonna just send the beginning address of the array to the function. The function is gonna take this value. Are you a delimiter? No. It's gonna get next element. Are you delimiter? No. So it's gonna continue scanning the function until it finds the delimiter, which is a special function. So we're gonna use 4, right? So here I don't use a delimiter, just array of numbers. Okay. So that means if I want to scan this one, I need to make a for loop 5 times. I need to loop 5 times. Every iteration I have to loop in one element. But if you use a delimiter, I have to make a while loop, while until I find the delimiter. Anyway. Okay, guys, any questions? Okay, so I'm gonna maybe same thing for this one, but maybe I'm gonna just skip it, but it's the same thing, DCQ. This is if you wanna define a variable that is double word. So double word means 64 bits. That means it's gonna take 8 locations. 8 locations, okay? And the other 2 things we can do, okay? Something we call it space, something we call it fill. Okay, so they are gonna be used if, okay. So now I explain how can you make array, okay? And how can you initialize the array? Let me ask you a question. For example, if I wanna make array of 100 elements, the way I explained right now is not practical, That means the way you explained right now, you have to put you have to put 100 comma, right? Because I have to put all of them. What if the array is 1,000? So should I write 1,000 comma? No, it's not. So in this case, if your array is too big, something like that, and it is uninitialized, so there is no initial value like you have to put there. In this case, you can use space and fill, as I'm going to explain right now. Okay. So how space works? So what space is doing, for example, here again, you have to put here a name, any name, okay? And then you have to use the keyword space, and then you have to tell how many bytes do you need, and this one is gonna fill all the bytes. So what this one is gonna do, guys? What this one is gonna do is gonna reserve 7 bytes. So this one is number of bytes. So 7 bytes. And this 7 bytes is going to put zeros in all of them. Automatically, it's going to put zeros in all of them. And P is going to point at the first address. You got what I'm saying? So usually, this one is useful if you want to make like a very big array and you don't need to initialize it. You understand what I'm saying? So you can use this one. For example, I want to make an array of 100 elements. Okay, I can put here 100. But using comma, it's not going to be practical. You understand what I'm saying? So we have this one, you can use it this way. Also, I have another one which is called fill. So in case this one space, again, you just put a name. This name is going to be replaced by the beginning address. This number 1. Number 2, automatically this one is going to fill all this location with zeros, nothing else. It cannot do anything else, zeros. And also you have to tell me how many bytes here. That's it, right? Okay. The other one, which is fill, this fill is similar to space, but you can fill with any other number other than zeros. Space, always 0. Okay. So the way you can use fill, as you see here, again, it can be any name, and then you have to use fill, and then you have to tell me how many elements you want to make. And you have to tell me what initial value you have to put in them. You have to tell me how big every element, 1 byte. You got what I'm saying? So for example, let's look at this one. In this one, here, that means I need 10 elements. Every element is 1 byte, and this is the initial value. So if you do this one, and that's what you are going to do tomorrow. So what you are going to see, I'm going to see 10 locations, 10. Every one is a byte, and the initial value is F for 10 locations. And F is going to point at the first location. Okay, guys. So this one is similar to the space, but this one you can change here in number. Also, if you want, you can change, instead of making 10 elements of bytes, you can make 10 elements of, if you put in number 2, for example, so you can make 10 elements of half words. Okay, so this one here is gonna tell you how many elements, number of elements. This one can tell you every element is a byte, or how many bytes in each element. Okay, so here every element is just 1 byte, and this is the value I'm gonna repeat. Yes.
How much is that? Okay, 20 bucks.
Yeah, sorry, this is a typo. I corrected it. So I think in the current version, thanks for bringing this one to my attention. Yeah, so actually what happened, this one, I'm gonna tell you what happened. Originally, this one was 20, right? And this comment was okay. But when I tried to generate a figure like this one, I found 20 as too many. It took too big space. So I thought, no, that's too much. That's why I made it 10, but I forget to change the comment. You get what I'm saying? Anyway, so now let me, and that's what we're gonna quiz. Tomorrow's quiz is gonna be something like that. Okay, listen to it. Any question before I tell you how the quiz will look like? Okay. So the quiz tomorrow, guys, I'm gonna give now after what I explained. Hopefully, I'm expecting that you understand what this means, what this one means, what this one means, what this one means. Okay, so what every one of these, that's what I explained, means. Number two, you should understand how they are going to be stored in memory, right? So some of them are bytes, so every byte is going to take just one location. Half a word is going to take 2 locations. That's also something you should understand. Other thing you should understand, when F is going to be replaced by the beginning address, this one also is going to be replaced by the beginning address, and so on. Okay, so what I'm going to do tomorrow, first of all, what I'm going to do tomorrow in the quiz, I'm going to give you something like that, and then I'm going to ask you to show me the memory, how this was going to be stored in memory. So I'm going to give you something like this one. I have another example here. No, sorry, it's the same example, okay. So I'm gonna give you example, something like that, and then I'm gonna just test you. I want to make sure you understand what I said, and you understand how this one will be stored in memory. This is for the quiz. For the lab, which is very easy lab, I know I posted it today, but anyways, it's just very easy lab. So in the lab, I'm gonna give you comments like this one. I already give you comment like this one. Define a variable byte, okay? And this is the name of it. And then you have to give me this one. That's it. Very easy, right? Anyway, so let's go through this one by one. Okay, look here, guys. This is the data area. Okay, that means I'm gonna assume we start from the location 2000000. This is the beginning address. Okay, and so that means how this one will be written in memory. I told you we are gonna start from 2000000, guys. Okay, and then what this one should do? This one you are gonna take 10 elements. Every element is gonna be 1 byte. That means this one in total is gonna take 10 bytes. 10 bytes in total. Make sense? And in every byte, this one is going to store FF. Okay, for 10 bytes. Is that okay? So, okay, so it's gonna be something as you see here, guys. Look. So, as you see here, I'm gonna start from the location 2000. Okay, and then we are gonna have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 10. So this is actually what happened from this instruction. What this instruction is did is actually it's going to be stored this way. Okay. Also, what if means when I use this label, whatever the name of the label, when I use this label. So because this one is going to have addresses, as you see here, this part 10. It should have 10 addresses. So it should have the beginning address, which is 2000, and the last address should be 2000009. Okay, this is the last address. So 10 addresses. Okay, so when I use F, so F is going to be replaced by the beginning address. Okay, guys, any question? You understand? If you didn't understand, please let me know. You understand how this one is going to be stored in memory here this way? We're gonna start from 2000. It's gonna go all the way until here. Any questions? Okay. Next one is gonna come after this one. So here we ended at 20009. So next one should start from 200A. Because after 9 is not 10. After 9 is not 10. After 9 it's 8, right? Because this is not decimal, it's hexadecimal, right? So the last address here was 2000009. Okay. So now, so after that, this one is gonna come after this one. Okay. So if I write something like that, so what is this? Very simple. DCB. This is array of bytes. Array of bytes. Is that okay? When you define array of bytes, guys, if you put numbers, that means every number I'm going to store it in a byte, as I explained before. But if you have a message is also array of bytes, right? But I don't need to just to put it this way, and the compiler is going to convert every character to the ASCII. You don't need to do that by yourself. You can, but don't bother yourself. A compiler can do that. Okay? So what I did here, guys, here I'm defining a message. A message means it's an array of bytes. It's an array of bytes. Okay. This is the name. The name is hello. So as you see here, guys, this one is going to be stored this way. So number one is going to come after this one. So the beginning address should be 2000A, right? And it's going to go until this one, which is 000016. This is the last one. Okay? Because everyone here is going to take a byte. So but it's going to be stored in ASCII. So here H, uppercase H is 46. This is the ASCII. Right? If you don't believe me, go to the table and check if that's true or not. Okay. E, the ASCII of E, the ASCII of L, the ASCII of L. Okay. The ASCII of O, the ASCII of space. Space is 20, as you see here, right? And so on. Quotation is not stored. Quotation is not a part of. It's not stored. Okay. So, and then after that, I'm gonna put number 0. So 0 is gonna come at the end here. Number 0. Okay, guys. So message is array of bytes. That's it. Just put it this way, and then everyone is going to be stored as you see. Everyone is going to take one address, one location. And what come after the comma? It's a number, because anything outside the quotation is going to be stored as a number. Inside the quotation, it's going to be stored with ASCII. It's ASCII, right? Okay. So again, when I use the word hello, because now we have many addresses here. We have too many addresses. So when I use the word hello, so hello is going to be this one, the beginning address here, the base address. Okay. Let's see more. Okay. Then after this one, so the last one here, as I told you, it was 200016, 016. So the next one, which is this one here, what this one is? This is array of bytes. Okay. So as you see, how many elements you have? 1, 2, 3, 4, 5, 6. And as you see here, 1, 2, 3, 4, 5, 6. Okay. And so here you can see this one here should be FF, right? This one here, 3A, hexadecimal 3A should be 3A, right? This one here, 10. This confusing to students. 10, when you go there, you are not gonna find 10. You find A, because A is hexadecimal of 10. That's okay. This one is 200. You are not gonna find 200. You find C8, because C8 is the ASCII of is the hexadecimal of 200. Is that okay? So again, when I use the word again, if you see here, this one, how many locations? It has too many locations here. So when I use the word dollar, in the code, so it's going to be replaced by the beginning address, which is this one. Okay. Let's see the next one. Next one here, guys. This is here. I define a variable. This variable, it's a word. So this one should take full location. It's a word, as you see here. It's going to be stored in full location. 1, 2, 3, 4 locations, as you see. Okay. Again, when I use the word scores, so it's gonna come from the beginning address. Okay. Let's see next one. So we are done until scores. So okay. So look at this one. Miles DCW. I told you W means half word. So this is array, because once you see comma, so it's array. Every one of them should take 2 locations because it's a half word. So this one is going to be stored 2 location, 2 location, 2 location, and 2 locations. That's exactly what happened. So we're going to start from this. We're going to start from this location here, okay? And then as you see here, every one of them, so 100 is going to be these 2 bytes are 100. Okay, simply because this is hexadecimal. After you convert them to hexadecimal, these 2 bytes are going to be 200. These 2 bytes are actually 50. These 2 bytes are actually 0. Okay, guys, any questions? Okay. Then next one, we are going to have seven bytes. All of them are zeros. Yes, and that's what happened. You can see 7 bytes, all of them are zeros. Okay, and also because these 7 bytes should start from this location. So you should start from this location. Okay. So that's why when you use P, the name P is going to be replaced by the beginning address, which is this one. Okay. And why you do this way? Because as I told you, if you have an array, I need the beginning address. Okay, then I can scan from the beginning address. Anyway, so let's see next one. It's the same thing. Next one, this one is gonna a byte. It's gonna take only 1 location. Okay, and that's what happened here. 010101 is 55. Don't be confused. I know this little thing is confuse the students. Okay, this is hexadecimal, this is binary. Okay, so they are the same. Okay. So 100 is 55. Okay. The last thing here, I want to define again. This is a name. I know in C language this was a keyword. It's not a keyword here. It's just a name. Okay. So here I want to define. I want to define a byte that store only one character, similar to what we did in C language. Okay. So you can do it in 2 ways. One way, I can define a byte, variable byte, and then I can store the ASCII. Okay, or I can, it's also a variable byte, but I'm gonna store it this way. Okay, so I'm gonna put the character this way, and then as you see here, the compiler is gonna convert to 41. Look at what I'm saying. So instead of doing it this way, I could have done it this way, but again, I don't recommend it. Don't bother yourself. Okay, so I can say character DCB, and then I can say 41 0x41. They are exactly same thing because you are going to put here 41 anyway. Okay, but 41 is the ASCII of A. Just put it this way, and the compiler is going to replace it with 41. Any questions? Yes. Okay. So if I need the ASCII code, I will give it to you. Okay. You already have it in chapter 1, and it's open book. You can use chapter 1. You can use the slides of chapter 1. I don't need, okay, to give you the ASCII. And man, even if I don't give you the ASCII code, once you tell me what should be stored in this location is the ASCII of letter A. Okay, that's enough for me, right? At least you know the knowledge, right? So that's enough for me. Yes. No, there is no reason. It doesn't matter. Any lines here, it doesn't matter if you have line or not. You mean here, line here between them? Oh. Oh, this one's because this one is the remaining of scores. Oh no, I think this is just a okay. This is just a mistake. Okay, just ignore it. Okay, but you are gonna start from 24 anyway here. So this should be started from 24. Okay. This is something we call it sometimes for optimization, to optimize it. Sometimes the processor is doing something we call it padding. So padding, that means sometimes every variable or every array should start from a certain address. to optimize the performance, if we don't do that, you can add some padding. You get what I'm saying? So anyway, so if there is no padding, you should not see it. It should be okay. You get what I'm saying? But again, sometimes a compiler, I didn't put them, but sometimes a compiler, in order to optimize the use of memory, they do some kind of padding. Padding means they can add some bytes you didn't put, because this can make the performance better if you start from certain addresses, something like that. Yes.
So it's like a buffer zone that's supposed to make the code run as optimal as possible.
Something like that, because when they read the memory, okay, they have some mechanism to do that, and in order to read the memory, they efficiently, okay, they have to start from certain addresses. For example, if you read, for example, 4 bytes at a time, you got what I'm saying? So if you don't start, so that means every variable, if it should be, you have to create a boundary, or you have to block for something like that. Okay. Anyway, it's not, you are not going to see it all the time as just for optimization, but what I'm expecting you to tell me is going to be stored this way, or what we are expecting to, as I explained to you. Okay. Any questions? Is it difficult? Just look at this slide. Understand also all what I need for tomorrow. Number 1, the quiz will be something like this one. I'm give you all what I need from you today to study, just to understand how can you use these keywords. I'm gonna post after this lecture. I'm gonna post the I'm recording the lecture, so I'm gonna post it just in case. I'm gonna also send you an email to tell you I have posted the lecture, just in case if you want to listen to it again. So all what I need I'm gonna give you something like that, and then I'm gonna tell you, show me the memory. It doesn't, because I got this one from the compiler, but if you do this way, I'm totally fine. It doesn't need to be horizontal. It can be vertical. Whatever is the way you do it, should be okay too. Okay. Any questions? Okay. Now, before I continue, now we agree. If you have a variable half word, okay, this half word should be stored in 2 locations. We agree on that, right? Okay. For example, yeah, I just need empty space. For example, if I do DCW, I'm going to say speed. So here I'm going to define a variable called speed. So here 0x, so for example, it's going to be 3a f2. Okay. What this means, assuming we are going to start at location 2000000. Okay, 0x. That means what this instruction is going to do, this instruction is going to take 2 locations, 2000000, okay, and we're going to take 200000001. Okay, guys. So these 2 locations, 2 bytes, I'm gonna use them for this variable. Is that okay? That's what we agreed on. Is that any problem? Because we agreed from the very beginning, every location is storing only 1 byte. Okay, so if you have a variable like this one should be stored in 2 locations. Is that okay? Okay, now my point is that how this one will be stored. The way it will be stored, guys, as you see here, we have 2 bytes, 1 byte and 1 byte. We have 2 locations and we have 2 bytes. Makes sense, right? 2 locations and 2 bytes. Okay, guys? Okay? Makes sense, right? They can fit because 2 bytes, 2 locations. That's okay. Same thing, if it is a word, we're going to have 4 bytes for location. That's okay. Now, what about the order? Are you gonna look here? I'm totally fine. You have 2 addresses, 2000 and 2001. I'm totally fine. And you have least significant byte and you have most significant byte. Totally fine. So what about the order? Are you gonna put here the least significant byte and you put here most significant byte? Or it's gonna be the other way, right? Number 1, does it matter? Number 1, it doesn't matter as long as the way you read is the way you write, right? So if I put here all the time, if I put here the least significant byte, I put here most significant byte. When I write, I will follow it. When I read, I'm gonna do the same thing. By this way, when I write a number and read a number, I'm gonna take the same number back. I'm not gonna make a miss, right? That's okay, but this is one approach. some processor to the opposite, which is also totally fine. So I can put here the most significant byte and put here the least significant byte, which is also, however, again, there is no problem. The order, it doesn't matter, okay? As long as the way you write is going to be the way you read. So once you do this way, if you write a number and read it, I'm going to get exactly the same number. Is that okay, guys? So there are two approaches. So maybe I'm going to, yeah, here. There are two approaches, as I told you. We have the low address, which in this example, it was 20000, and we have the high address, which is 20001. So I have two addresses, I have 2 bytes. There are 2 ideas. One idea, we call it big Indian, and the other idea, we call it little Indian. So the difference is that in case of little Indian, so I'm gonna store the least significant here and then the most significant. So the low address, the small address is gonna store the least significant, okay? But here, I'm gonna store the most significant here and the least significant next. So in the low address, so you can see the order just different. Okay, guys? So now, okay, just 1 second, okay? So now, what I want to tell you is that some processor are doing, again, you should understand, it doesn't matter as long as when you write in a certain way, if you read in the same way, you're going to get the same number. It doesn't matter, right? However, some processor are doing this one, some processor are doing this one. So sometimes when you go to a processor, the processor is going to tell you, I only use little Indian. Some processors are using big Indian. For ARM processor, you can use both of them. You can use both of them. Okay. This why I'm mentioning this, because you may be confused when you come here. For example, let me tell you, give you one example quickly. For example, if you look at scores here, guys. For example, if you look at the scores here, or if you look at this one, for example, here. So if you look here, for example, you have 100. Look how the 100 is going to be stored. Sorry, miles. Where is miles here? Yeah. So how the 100 is stored? Look, guys, here is going to be 6400. So actually, the 100 should be 0064. This is 100, 0064 in hexadecimal. So the way you are going to store it, I'm going to put here the little one. I'm going to put it first, and then I'm going to put the most significant next. Okay, guys? Again, this is just 2 different things. It's the same idea, exactly same thing. I'm going to beat it tomorrow, but let me finish it, and I'm going to beat tomorrow. So it's the same thing. If you have a bigger than a word, for example, here in case of, sorry, bigger than half word. For example, if you have a word, it's exactly the same idea. I have 4 locations and I have 4 bytes. So again, what is the order? If you put the least significant byte first here, and then the next one, and then the next one, and the next one. So this little Indian. If I put here, if in the small address, if you put the most significant byte and then next one, and then next one, and next one, that's what we call big Indian. Okay, guys? Any questions? I'm gonna repeat it tomorrow anyway, this part. Okay. Thanks. See you tomorrow.